Hello, this is Jeffrey Fox. We're beginning this next lesson, which is Lesson 3, Unit 2, section on Sports Informatics or Analytics. And this is all on PitchFX. And this is all in the Big Data Applications Analytics course. Thank you very much. Thank you very much. Let's get going on the lesson. Hello, this is Jeffrey Fox again. Lesson 3 of Unit 2 on Sports Analytics or Informatics in the Big Data Applications and Analytics course in Data Science. And here we're going to discuss some various uses of PitchFX that I found in the on the web. Again, this field is like many other big data areas. This big data is so valuable that it's very difficult to find anything but very qualitative discussions anywhere. So this is qualitative again. It's just a few places I found some information. Here's some example of PitchFX. It right-handed batters, and it just records the vertical location in the strike zone versus the horizontal location here, vertical here. And the reds are called strike by the umpire, and the greens are called balls. You can see there is a little bit of screw up here, but not too bad actually. There is some, especially here and here, indication there's a bit of a problem, but and that quite why this one became a strike is a bit unfair on the poor old batter. Never mind, it's not too bad. And of course, you could do this in real time and actually make your computer call the strike or the ball, but maybe that's not in the spirit of a good solid. So now we come to another discussion of PitchFX we found coming from Vince Gennaro again, who had that great set of discussions of clustering pitches, and he analyzes changeups. So I actually don't quite know how changeups are decided in the real world without PitchFX, because obviously probably the pitchers usually know whether they threw a changeup or not. At least they presumably know if they try to throw a changeup. And PitchFX can try to classify with some classifier, which is machine learning, based on the record of the ball's motion, whether it was a changeup or not. Anyway, so we didn't actually decide what the algorithm used by PitchFX was. It just looked at some statistics which could be used. We'll go on later on to actually not only on a bit about a particular pitcher, how you classified his pitches. That was from a different analysis I found on the web. So changeups are meant to be 14% of all pitches. They're slower by 7.6 miles per hour than the average fastball. They move a total of almost 12 inches, of which 4.4 is vertical, and which is about a third of the total, and the rest horizontal. And here on the slide, next slide, which we'll go and look at, we actually have a whole bunch of pictures and then a measure listing of what their changeups do. And Justin Verlander is a pitcher. Again, it's not a I'm not an expert on baseball. It turns out he throws a changeup 34% of the time, and the good reason he does that, he actually gets a lot of movement on it. So, and he has Gennaro has a formula for changeup point, which he's going to use in his features in classifying pitches, but he doesn't tell you that formula. And obviously, you're going to use this particular analysis to come up with the performance of batters against changeups. I mean, of course, you needn't necessarily do this. You could actually do it instead of having changeup, slider, fastball. You could just have speed of pitch, vertical displacement, horizontal displacement, and so on. And you needn't use these qualitative descriptions. Anyway, we're using qualitative descriptions. So here is this nice chart from Vince. Here is Justin Veranda. He's the number one in most criteria for change up. He's got 109.7 points, which I told you we didn't know how to calculate. He has a total move of 15.4 inches, a vertically 8.3, 7.2 miles per hour velocity difference. And he throws it 33% of the time, or 33.6. Here is Jason Vergas. Didn't get quite as many points. He actually has more movement. He throws it somewhat less often. Wow. Too much lecturing makes me cough. I apologize, and so on. So you can see how you can actually classify, and whether I say I'm not so certain you can't just use these numbers. Ignore these numbers, these change-up points, which you don't know how to define. But we can use these things. Actually, you probably want to just use vertical movement, but we can use here. We've chosen total and vertical, velocity difference, and probably fraction time. So these are 4 features. We could use those if we wanted to, rather than change-up points, because machine learning doesn't really care whether you have 1 feature or 4 features. It's just machine learning. It's very good at dealing with lots and lots of features. Remember when we did deep learning for face recognition, they had 11 billion parameters which we determined, and suddenly lots and lots of features. So I don't care about how many features we have. So that's old-fashioned stuff. We need to know the features we want. I don't think it matters in reducing them, because the big data technology will reduce the number of features. Because we know how to write optimization problems where if you choose a feature which the optimization doesn't depend on, it's okay. It will ignore that things. We know how to. We have robust optimization methods which are insensitive to over-parameterization or over-featureization. Okay, so here is points out the WL-BAM, which has this game day thing. They use a neural net to classify the PitchFX pitches, and here's a fellow, Luke Hochevar, who here we have his fastball speed plotted against innings. He obviously gets a little tired. He starts off at 92 miles per hour, ends up more like 91. And if there are men on base, he's a little nervous, and his fastball has a slightly, his men on base is red. Blue is no men on base, and the red one is somewhat lower performance. So these are all. I told you some of these statistics you actually can plug into formulae. Other statistics you can just tell Luke, "Hi Luke, this is your fastball. Maybe you want to get less nervous and throw faster with men on base." I don't know. Well, maybe he wants to be more accurate. So we have to look at speed and accuracy. Or actually, what we really want to know is runs given up. So this is not actually the right. MPH directly is not what you want. You want to know what speed and what type of pitch with what velocity, with what movement are the right ones to throw with no people on base, 1 person on base, and so on. You ought to be able to find this out from all this data. All right, and here is actually a pretty amusing plot. Here's Luke again, and his performance in September 2009. Here's some NEV plot speed here, and we plot here horizontal deflection. And here we have sliders, curveballs, 2-seam. I don't know what a 2-seam fastball is, a 4-seam softball, and the cut fastball, and change-ups here. So these are classification with some of the features. I assume that the classification depends on multiple features, and of course this is a problem. Well, you can plot 2 dimensions, 2 variables on a slide. PowerPoint is 2-dimensional. If you're a real person, you can visualize in 3 dimensions because you live in 3 dimensions, and you can rotate and see. And that would actually allow you to do pitch speed, horizontal spin, and horizontal deflection and vertical deflection. But you can't do 10 10 dimensions, and maybe these are all in 10 dimensions. This is the well-known challenge of high-dimensional data. How do you represent them? So that's the end of this lesson, and we'll move on. We have one more lesson to go, and now I'm signing off. I'm Jeffrey Fox, Big Data Application Analytics, Sports Informatics, second unit, and we're discussing PitchFX. The last few slides in the final lesson tell you about the other measures like HitFX and FieldFX and so on. Thank you very much. Signing out.